Hello, this is Mark Tucker,
Hey, I'm Allen Firstenberg, and we are Two Voice Devs.
Two Voice Devs.
Hey, Mark. Good to see you as usual.
It is good to see you too. Uh,
Ah,
you've been really busy doing some fun things. I got a sneak peek last week on some things, and I think we finally get to talk about some of it.
we finally get to talk about some of this. I have been working furiously for the past 3 months, ever since the Gemini API competition was announced at I/O, with some killer amazing stuff, including an electric DeLorean, which
Whoa.
I'm not gunning for, but it's cool. And I'll show some pictures of the DeLorean here. Including that. But more importantly, I think, is that they were the goals of the competition really seemed to me to be to not just create a simple make something that's attached to a prompt,
Yeah.
but really try to get people thinking about how do you start building these more complicated tools with Gemini. How does this fit into bigger pictures? How do you use it with Android, and how do you use it with a web front end, and how do you use it
Yeah.
with Dart and Flutter and other tool sets and Firebase, and so forth. How does it all fit in together? Is what you're doing innovative? If how you're doing it innovative? So it's more than just can you create a single really cool prompt? It was can you build a system that has Gemini as part of it? And first of all, I'm really excited to see what everyone is doing. How did people really understand that? And are they delivering on it? First of all. And then second of all, what are we going to see? And then third of all, and the selfish aspect of that is, and could I pull it off with my own, what I was trying to do? And I hope I did. That's one of the challenges, is to see if I really could pull off a complicated agentic system that I was picturing in my head. And I don't know. I hope I did. We'll see if the judges agree.
Yeah, well, I watched the video that you have posted, and I'm sure you'll provide a link for others to see what you did. But I'm pretty excited about it. It's something that I think it was something that we talked about the very first time we met up at a conference. Was we're just kind of talking about what we were doing with voice technology, and you were talking about Vodo Drive and being able to talk to spreadsheets. And I was like, this is kind of intriguing. But what you've done now with the ability, pulling in Gemini and generative AI models and images and plus the voice aspect that we had talked about is definitely next level in my perspective.
And that's kind of what I was going for. Was for those of you that have not heard me prattle on endlessly about Voodoo Drive, the kind of goal with Voodoo Drive was to say, what does voice control of a spreadsheet sound like? What does it feel like? What can we do with a spreadsheet? And if it was ubiquitous, if it was just there, if we could just issue commands and have it happen. Voodoo originates with the first bits of code that I wrote for Glass, was trying to create this visual to-do list, which is where it got its name, on Glass, so that you could look at a to-do list through Glass and talk to it and check stuff off. And that was controlled on the back end through a spreadsheet. And from there, it's kind of evolved into me saying, well, okay, what does voice control of a spreadsheet look like? Because when we think about spreadsheets, we think of cells and we think of moving between cells, but it doesn't make sense to say things like, go to cell A1, set the value to 5. Go to cell B1, set the value to 7. That doesn't make sense.
Yeah, that you kind of envision, because when you first were describing it to me, I was like, so you're at your computer with the spreadsheet in front of you, and you're using something like Dragon, naturally speaking, and directing the spreadsheet to enter in values. And I'm like, that doesn't seem very intuitive, but it's not. It's nothing like that. It's yes, behind the scenes there is a spreadsheet, and you know you have different spreadsheets for different things, but you just talk to your assistant and add values, and just kind of while you're doing something in the action of something, or when you remember that you just speak it and it finds the right spreadsheet and it enters the right value. And plus now it has the ability to answer all kinds of more natural language queries that you've got. It's not constrained to the typical utterance intent models that we had worked with.
I need to get you to explain it, because I think you explain it better than I do, to be perfectly honest. But that's it exactly. When I started doing this for the assistant, it let us do things like, open the scores spreadsheet, set the value of miles run to 3. So it was getting there, but it still felt very unnatural. Right. It still required you to say things in a somewhat controlled way. And over the past year and a half, I'd been experimenting with, well, how do we use the natural language components of large language models to understand what it is we're trying to do? And when it does that, how do we teach it the structure of a specific spreadsheet? And how does it, use all of these factors together to do things that we couldn't do before? A couple of years ago, I had somebody ask me, wouldn't it be great if you could have it set a cell to a formula, if you could tell it the formula? I'm like, you can't do that. There's no way you can do that.
Yeah.
That's too complicated a thing for a person to say. And it's way too complicated a thing for the natural language understanding systems we had at the time to handle. And in 2 years, well, that's where we are now, and that's what I was demonstrating with this project, was just make it so that I could speak to this system and say, record the fact that I ran 3 miles. And it would open the right spreadsheet, add a row, record the values. It would do this set of things, and all I as a developer needed to do was tell it what capabilities it had.
Right. And
Gemini was able to piece this together into a chain of actions that needed to be taken. And that's new, that was powerful. And I really liked that. And then I took it a step further. And I said, well, going back to my Glass days, one of the things I really would love to do is just to be able to, point it at something and say, hey, that information, save that in a spreadsheet. And I wasn't sure.
You're talking about the camera on Glass.
Right.
Right. Just looking at something and say, capture this thing. Well, and what are some examples of those things that you would want to look at and just record?
Well, the thing that I always really wanted to do was, I still have a gas-powered car, and I like to record how much I spend on it, how many miles, it took in between fill-ups, and, so what's my mileage on the car, and how much is gas costing me per mile, and stuff like that. And I had a spreadsheet for a number of years that did that, and I gave that up after a while because it was a pain to record.
Yes.
But if I could literally just, as I get the gas, point it at my odometer, say, this is my current mileage, point it at the gas pump and say, here's how many gallons and here's how much I paid for it, go put all of that in a spreadsheet.
Right.
That, it's not quite frictionless, but it really drastically reduces the amount of friction to do something.
Well, and what I notice, and we'll get to it, is that you can take a picture and you don't have to say, put this someplace, tell it where to put it. It's like, oh, this is the thing that you're looking at. You must want to put it over here.
Well, the kind of way that it's set up is that it collects the data from the picture, and I can say, and I have to say, I do have to give it an instruction to do something.
Right.
It won't just automatically do it, but I can say, save this information that I just provided you, and it will look at it and say, okay, so this was mileage information and this was gas information, and you've got a spreadsheet named car gas mileage. So I'm going to add a row to the car gas mileage spreadsheet, and I've got this field and this field and this field, and put it in there, and then tell you what the result is. I need to nudge it a little, and that's intentional in some ways. I don't want it doing things automatically.
Yeah.
I want to make sure that I, as a human, am in control of it. But once I've done that, it's taken care of huge chunks of what I previously had to guide it to do step by step by step.
I don't know. I just keep thinking about. I was watching something recently about the Star Trek computer again, and just thinking about your camera input or your voice input are like the sensors, right? And what you could do on the Star Trek computer is like, look at these sensor readings and process some information and give me an answer, or and I'm just like, this is kind of the same. That we're getting into right now. It's visual input, but it could be in the future. It could be sensor readings. Maybe you've got something that's automatically on your car that could be adding stuff, or you could. There's just like a whole infrastructure where you could get data from lots of different places and still process it through.
Exactly. One of the things that I think is something you and I have talked about now for 4 years.
Yep.
And that's, our conversations need to be in the context of something. There is a bigger context out there that,
yes,
as developers, we need to be aware of and we need to incorporate in the conversations. And to me, this was me saying, there's more context than just saying or typing something in.
Yeah.
How do we tap into that context? How do we make it so that the world around you is something that you can include in your spreadsheets when it makes sense to do so?
Yeah.
And that was my goal here. And then the third half of this was being able to say, okay, great, I've got this spreadsheet of data. That's wonderful. How do I get information out of it?
Right.
And being, and it used to be the previous version of Vodo Drive for the assistant, I could give you whatever was on the last line. And I always had these kind of visions of it would be great to kind of make it flexible and ask, let you come up with bigger questions. But they were always amorphous questions. I didn't know what questions that I was able, I could code for. I didn't know what questions to code for. And now I don't need to. So now you can say things like, what's my average gas mileage this month? Or how much did I spend on gas last month? And since I can represent that as a formula, it's a spreadsheet after all.
Yep.
Then so can Gemini. And if I have Gemini turn that into a formula, I can then plug the formula into a Google Sheet to give me the answer.
Interesting.
And that's what Vodo Drive does, is for every time you've got a query or a question, it asks Gemini to turn that into a formula and then asks the spreadsheet to run the formula to give you an answer.
That's interesting. So the spreadsheet itself is the compute power for figuring out the answer to the question. So large language model is great for figuring out what was said and how to formulate that into a query that the spreadsheet can understand, but it's actually the spreadsheet that processes it.
Exactly. And I think that's important. One of the things that I think a lot of people have found very challenging when dealing with large language models is they want the large language model to do everything. And when it can't do everything, then to say, well, okay, let's create a module that the large language model can write a program that does everything. And I'm not sure these are the best solutions. I think, truly we want to use components that make the most sense. And when you're talking about number crunching, that suggests a spreadsheet or a database or, some other specialized tool that is good for doing that number crunching. Let's use the right tools for the right job. And in this case, very much spreadsheets are the right tool for most of the questions people are going to be asking about their spreadsheet. And I think that's, we talk about retrieval augmented generation. And a lot of people, when they think about RAG, they think of it in terms of, I'm going to have a vector store and an embedding model of my text. And that's great if what you're searching for is text. But if you're trying to do number crunching, you need something else.
Yeah.
And spreadsheets are one of those something else's.
Very interesting. So are we going to get into some detail?
Let's get into some details. Now, I'm not going to be showing code for a lot of reasons, but I do think it's important that we talk about some of kind of the overall system design here, because I think there are a lot of lessons that people can learn from the system design. And again, if you go look at the video that I made, we were required to submit a 3-minute video, or up to 3-minute video, describing the project, which I did. And as part of it, it includes this system diagram, just kind of describing what I did. And I, as part of it, I looked at the system diagram that I did for the last experiment, and there are like 3 times as many nodes on it. So this is a dramatically bigger implementation than what I had done last time. And I very much, I feel like the work that went into it kind of reflects that as well. The core of it is this core system that was running on Firebase Cloud Functions. And if you remember a few weeks back, we were talking about hosting stuff. And I said I was hosting this project I couldn't talk about on Firebase Cloud Functions. This is the project. In many ways, it's a node server. There's nothing terribly dramatic about it. But this one, this was doing a lot of work in there. So this is the system that makes the connection to Gemini. It's doing the work with Gemini. It's doing the work with Google Drive and the spreadsheets. And it does all of this in a... I used a tool for the first time that I hadn't used before called LangGraph. And this is from the same people that did LangChain. So I wanted to give it a try because I knew it would work well with that. And it did work wonderfully well. LangGraph is kind of designed to build these agentic systems. And when I say agentic system, what I mean, and there's a lot of back and forth about what that actually means. What I mean by it is a system that makes multiple calls to an LLM and has some logic in it about what the next step is going to be. So what many of these do, for example, is based on a single user input, it will send that it will send that and a bunch of possible tools that are available to the LLM. And the LLM will send back, okay, based on that, call this tool with this parameter. You call, something then calls that tool with that parameter, sends the result back to the LLM, and it says, okay, now call this other tool with these parameters. And that keeps going in this loop until you've come up with an answer that the LLM thinks answers the initial question or fulfills the initial task or does whatever. So, for example, if I said, record this information in the spreadsheet, it needs to do things like get the list of spreadsheets. And then once it's gotten a list of spreadsheets, open up one of the spreadsheets so it knows what the format of it is. And once it's done that, it needs to add a row. And once it's added a row, it needs to put the data in the row. And then it needs to tell, so it's this loop of different things that it will do. And in some cases, maybe it means that, well, now I've gotten this list of spreadsheets, but none of them fit. So I need to bail out at this point. And sometimes, if I'm doing things like adding a formula, it will give me a formula and I'll put it in the spreadsheet and it will generate an error. So I now need to say, well, that didn't work. Try again.
Yeah.
So somewhere there needed to be a decision process of that try it again or how to handle things.
I'm assuming that you define different features or functions that your system can support, and it will try to use that information. You don't necessarily know in what order or how many of these callbacks to get more information to this, to this agent that it's going to do. but it's all part of a kind of a bigger process of trying to get to the end result. So now your LLM is not just doing natural language processing; it's trying to break things down into a set of actions that need to be performed to get to the result that you want.
Yes, exactly. And it's the responsibility of the agent to kind of navigate that, what the LLM wants you to do, and then to execute that in some way. So that's what LangGraph and the agent, what I think
Yeah.
of it as a loop, because it is a loop. And the agent loop does. And it's called LangGraph because it's set up as, and this is a nice computer science term here, it's set up as a set of directed nodes with edges between the nodes. That's a nice
Yeah.
technical term, a nice
It's a graph.
computer science theoretical thing here. It's a graph. Basically, we've got a bunch of different stages, and we have ways that will move in between those stages and something that controls that. And overall, we have this huge set of state, and something is managing that.
So is it, I guess, do you have an idea, maybe you know the exact number off the top of your head, but do you know how many different functions or tasks that are defined in LangGraph that can happen? And like how long does it take to call each of these tasks to gather information as part of the bigger process?
That's actually a great set of questions. So off the top of my head, I defined, I want to say it was somewhere around 6 or 8 different functions that can happen. And these are called tools. So 6 or 8 different tools. Each of those corresponds to 1 or 2 API calls. And the API calls will take, a few hundred milliseconds. So it was not uncommon for large commands to take upwards of 4 or 5 seconds. In the graph itself, I defined, there are 2 primary nodes in the graph. One is send things to the model. The other is send things to the tool. And there are a couple of auxiliary nodes that I defined there to check the output of the model and check the output of the tool and do some additional other formatting to kind of, just make some of the flow management better and make each node really fairly small and dedicated.
I do have a question.
Go ahead.
I remember way back when I was doing SQL, we were afraid of letting users kind of enter stuff in and have that turn into a SQL query because all of a sudden you can get a SQL query injection,
Yep.
So I'm assuming there's some sort of a barrier between the user input and what actually turns into calling a tool and the parameters that get passed to the tool. Is there a protective barrier so you can't do rogue things with your commands?
There are a bunch of different ways that we handle this, and this is a growing field of research in some ways. Some of it is doing sanity checking on the SQL or the function or the whatever to make sure that we're not doing rogue commands. Second is that the tools themselves that we're defining are limited tools and should be limited tools. So we're not, for example, there's no way to delete the entire spreadsheet because I haven't given it a command to delete the entire spreadsheet. There's no way to delete a file because I haven't given it a command to delete a file.
So you're protected by what features you expose externally. Like if you wanted to drop the database via voice through a tool, you could make that happen. It's probably not a wise thing to do, but you could.
You could. And there are people that, have systems that they just kind of turn loose on their desktop. And I'm thinking this is a ridiculously bad idea. And it's very important that we define the tools in fairly narrow ways for a lot of reasons, including security and safety, but also because the narrow definitions make it easier for the LLM to know which tool to pick and which parameters.
That makes sense.
I would not, for example, give it a function called run Unix command. Because that's over, I might give it a function called copy file, and I might give it another function called delete file. And if I was giving it a delete file, I would probably take some steps that the delete file function itself didn't
Right.
actually delete the file. It, hid the file, moved it to a
Yeah.
temporary thing, or, did something like that. So I as a developer should be careful
Okay, good.
about how
Sorry,
we
that was a
define
little bit of
those
a
things.
tangent, but it's
No, no, no. It's a great question, and it's a really important question because I think what it illustrates is, there's a lot of people that are like they're concerned about turning these LLMs loose on the world, and I'm thinking, what we need to do is we need to give them a fairly
yeah.
small
There
world
are
to play in.
guardrails, and that's I think we're used to guardrails in the world of intents and utterances because really you're only limited to what you've defined as far as the contract, and you have fallbacks if they say something that's out of line with what the your agent or assistant was supposed to handle. And so there were some pretty good guardrails in place. Plus the fact that old style assistance was very deterministic. You give it the same inputs, you always are going to get the same outputs back. Whereas now,
Right.
Gen AI stuff is less deterministic in that aspect. There is some variability. There is some hallucination, which you have to protect against, but there are still ways to put guardrails in place, which is a very important topic.
Exactly. And I think this is something we really
Yeah, I think
should
so.
cover in another show because it is important. There are a lot of safety issues that we should be that we will be covering again in the future. One of the things, though, that this multi-tool looping process kind of highlighted to me, though, was it brought up a bunch of conversations that we had in the voice field about how do we give
Yes.
intermediate updates. So one of the questions always was, I've got this long-running operation that's going to take me several seconds. How do I tell people audibly what's going on? And the answer back in the
Yeah.
Alexa world was, you don't. And in the assistant world was, you really, we've got this kludgy method, but you really don't. And I was determined to come up with an answer to that for
Oh,
this,
good.
and I did. And this was something that I'm actually really proud of. So one of the ways we normally see people dealing with chat bots and chat systems with LLMs is kind of this notion of you type something in, you'll get back a
Yeah.
response, right? And when you implement that, that usually kind of boils down to you're going to send a request and
Yeah.
wait for a response. But that's not how conversation
Yeah.
chat systems work. Conversational chat systems are anybody can send any message at any time. And, people can go and edit their messages and, things can change and you'll get smiley faces
Yeah.
on earlier messages and so forth. So that message has changed. And I wanted to more reflect that kind of a setup. Fortunately, Firebase Firestore is ideally suited for this. In Firestore, what you'll have is a collection of messages. And the messages don't have an inherent order, but you can build a field that has an order in them. And you as a client on the website can just subscribe to this collection. So when new messages show up in the collection, display them. And when old messages get updated, either because the message for them has finally come through, you display the update. So this now directly reflects what your messages with Vodo Drive look like. It's just a collection in Firebase.
Yeah, that is something that's always impressed me about Firebase is that it's a real-time database and you can hook up as many clients. What would be in like the pub sub world, you can have lots of subscribers and lots of different publishers as well, and all the subscribers get updates for all the public things that were published to the real-time database. And it's amazing that is it's been around for a long time, Firebase, with this functionality, and
Yeah.
it's always been kind of a delight whenever I've kind of come across it again and just remembered that, oh yeah, Firebase has this feature that if I wanted to do some sort of a real-time chat, I can do that, and it's just built in, and basically it's just adding records to this collection or to the data store.
And what's amazing to me is on the client side, it's literally one line to subscribe to the collection. You basically say, on update, call this function. And when that function gets called, it gets called with a list of updates. And you just go through that list and do stuff with the update. That's it. There's really nothing else to it. So I took advantage of this by saying, as part of that agentic loop, every time it triggered a new tool call, every time it was every time the LLM said, okay, go do this tool instead, it updated a message that said, okay, I'm now calling this tool. So as it's running, you can see exactly what's going on.
Oh, I did notice that in the video that you'd make a request and it would say, loading the spreadsheet, adding row. Yeah.
Opening, right. Adding a row, running query. So, and it was telling, and when it got an error, it said, trying again. So you got this update.
Yeah.
And that was really important to me. Because one of the things that was frustrating in the voice world was you'd just be sitting there for 7 seconds. You don't know if it's working, if it died. You don't know what happened. Here you are getting an update as things are happening. And that transparency was really, really important to me. That you could see what it was doing. What is going on with my data? Because it's my data.
And I had this conversation and I asked a question. And it gives you this comfort of, it's doing this, Okay, I can see that it's working, it's processing my request, and I guess one of the things that I like about this is that you're not tied into this 7 seconds that you have to get a response back. You can give a response back saying, hey, I heard you, and then you can get status updates. And then it can tell you the answer, kind of in its time.
This wasn't part of this system, but it's really easy to see how, if this was a pure voice system, it would say, okay, got it. Okay, I've opened the files. I've added the row. Okay, here's your answer. And you're getting that constant feedback and it interrupting itself as it's doing the work. And that's really, really, in terms of a user experience, that seemed really, really important to me. And I was just thrilled, it always thrills me when I can use Firebase like that. And you're right, I agree with you. Every time I encounter this, it feels like magic. There is just something about the Firebase real-time database or Firebase Firestore that just feels like magic. And that was that's a core component of this system. One of the other things, though, that I did that, again, uses the database is we've got this conversation between the user and Voodoo. But as you're going through that agentic loop, there's another conversation going on. You've got these intermediate results that are going in there. When you first uploaded your data, a picture, for example, that's additional conversation that's going on in there. So there's this parallel conversation that is happening between the agent, which is acting on your behalf, and the LLM. And that's also reflected as a conversation that's going on that has a bunch of extra intermediate states. And then at some point it truncates a bunch of those states because it now has its answer. And that's also stored in the database. So while you don't see it, or you don't see much of it, you see kind of glimpses of it, it's there and it's attached to the same conversation that you're having. But it's a parallel conversation.
If I'm hearing you right, the two big uses of that is to track the processing of either voice or maybe it's just image input, but processing of input as well as deciding what to do if there's an error when because in the end you have a tool that's going to eventually have some sort of formula that it's going to try to run, and it's going to come back with an answer, and it will somehow it will determine if it's a good answer or not, but it's got to kind of figure out what it needs to do next.
That's some of it. So it's kind of two things. One is that in many ways it maintains the data representation of stuff. So while you, as a human, see a human-like conversation. There's also a similar conversation where some of it is more the data representation. So for example, if I've sent in a picture, it's broken down what that picture, what the components of that picture are. I'm not going to see that in my conversation. I can get access to it if I want to. I can get access to everything going on. But I don't necessarily want to see that as part of my conversation. But the agent and the LLM need to see that as part of the conversation. So that's one part of it. The second part is when there's this back and forth between the LLM saying, run this tool next, and the tool running and giving an output. There's a back and forth between the two where you're getting a bunch of information, and there's creating a bunch of structured information that's being fed into the LLM. I want to know that the conversation is going on. I want to know what tools are getting called, but I don't necessarily want to see each call. So that's left out of my conversation with Voodoo, but it is part of this internal monologue almost that Voodoo is having. And that needs to be maintained somewhere. And maintaining that as part of the database made the most sense.
That made me think of something. So the data that you're working with in the spreadsheet, the LLM knows about its structure. It knows how many columns there are, what's the names of the columns. So it has some sort of, it gives some structure to, it's not just text that it's dealing with. It's dealing with some structure.
Right.
It knows it's a table, and it knows that these columns, and it can infer some things by the names of the columns, etc. Now, when you pass in data from like a picture, it's broken up into its properties. And so that's also structure. That's adding structure to this image. That's also could be used by the LLM to better understand the structure of the inputs and try to match it to structures of outputs. All right.
You got it. And that, this goes back to the philosophy I've talked about now for over a year of bridging the fuzzy human digital computer divide. Here's a case where we've got fuzzy human stuff in the form of spreadsheet columns and spreadsheet names and pictures. And it's up to Gemini to turn all of that into structured data and function calls with parameters and very digital computer attitudes. And that's a lot of what Vodo Drive is doing in this sense, is making that conversion possible.
Yeah, it's so looking at your diagram, we talked about the Firebase Firestore. We've talked about that it's a, is it a web app then? Like, is the chat interface a web app? So
it's a web app. Yes,
so Firebase is hosting that web page. Right, so that's the Firebase hosting site. And then you've got Firebase Authentication, because what you want to do is you want to keep your spreadsheets and not public spreadsheets. So you're once again using the power of these tools that are part of Firebase to allow somebody to log in, and then that behind the scenes is adding security to not only grant access to spreadsheets that you only authorize, but that's also providing a security context for Gemini to run within. Is that?
Not exactly. So what it's doing in this case is calling Gemini is done through Voodoo. And we can touch on that again in a moment, because that ties into how Firebase functions work. But what this does, it does two things. It provides both the authentication. So when you log in, this is me saying, okay, I know who this is. This person has an account. They're permitted to log in. They're permitted to use the system. That's authentication. And then it is the stepping stone to authorization. So this is where you say, I am granting you permission to access the files that you create or that you can access. And then it takes advantage of some Google trickery, legal Google trickery, totally legal, totally authorized, to give a file picker where you can explicitly authorize Voodoo to access these files. And that's using Google's authorization system. It's using Google Drive authorization. it's using a very tightly controlled set of APIs that are there specifically so that you don't have to say, let me have complete access to your files. I don't want complete access to your files. The fewer files I have access to, the better. But you do need a way to give me that authorization. And that's done with standard Google OAuth authorization systems. That's a fairly standard component, but it is tied into Firebase authentication and Google sign-in and standard tools on that side.
So we got our security layer, so both our authentication and authorization in there.
Yep.
So that's good. And then you said like the last component is Firebase Cloud Functions. As far as the kind of suite of Firebase tools go.
We've talked about Firebase Cloud Functions already. That's where the code is running. The final Firebase component that's in there is something called Firebase Cloud Storage. And this is the Firebase interface to Google Cloud Storage. And we kind of touched on this a little bit a couple of weeks ago as well when we were talking about the AWS equivalent, whose name I've again forgotten. What Firebase lets you do, though, is it lets you create this storage bucket and then create private spaces in that storage bucket. And those private spaces are only accessible based on, you guessed it, the authentication that they did using Firebase authentication. So this now creates an area in a cloud storage bucket that you, as your users, can upload files to, can download files from, and it's totally private. Except for the fact that the process running on Firebase functions can access anything in the bucket. So when you are uploading a photo, for example, you upload the photo to this bucket, totally private. You then send the message to Firebase Cloud Functions basically saying, I just uploaded a photo and here's where it is. The Vodo then grabs the file from the cloud storage bucket, processes it, and puts it into the rest of the conversation. Similarly, when you're doing audio work, there's two things involved here. The audio that you've recorded, you put in the bucket, and you say, hey, here's the audio. Vodo then does a speech-to-text transformation using Google Cloud speech-to-text tools, not using anything with Gemini here, puts that into the conversation, and puts it into the chat that you're having with Vodo. So it appears in your chat as text with a little link that you can listen to the audio if you wanted to. And then when you've done that, it needs to reply to you similarly. So it will do text to speech, put that audio in the bucket, and give you the URL for that audio so that you can listen to it again in your chat system.
So for speech to text and text to speech, are using kind of out of the box, been there for a long time, processing ASR and TTS.
I'm using the existing Google Cloud capabilities that support that. These are well-established.
Then exactly what is Gemini used for?
Gemini is used in two distinct ways. One is when you upload a photo, I send the photo to Gemini and with instructions to, give me a JSON representation of what you see in this image. So if I took a picture of a gas pump, for example, it would give me fields like object, gas pump, gallons and a number, total price and a number. And, depending on how much, maybe it'll give me the brand name of the gas pump, maybe, depending on how much of a picture I took. It captures all sorts of interesting, finds all sorts of interesting information. I think one point it said something like, primary color. Okay. That's not useful in this case, but that's it. It found that as a field. And in other contexts, it might have been useful, but it didn't in this case. So I use it in that way to turn this image into a structured JSON object. And then I use it as part of the agentic conversation to say, here's the input, tell me what tools I need to run. And then after each tool, giving it the output of that tool and having it determine the next step. And then when it's done, coming up with a final
Okay.
response.
All right, that
back
makes
to the
sense.
user.
Question about the image to text or image to structured property JSON, right? Have you noticed that, like, how well does it do across like similar things but like different pictures, like gas pump at gas station 1 versus gas pump at gas station 2? Is it going to name things similarly, or is there?
No. I mean, what's actually quite remarkable to me is I will give it the
Yeah.
same pic. While I was testing, I was giving it the same picture over and over and over again, and it came up with a different structure
So it's
every
not
single time.
necessarily going to give you kind of a standardized, structure. It's going to try to figure it out, but maybe that doesn't necessarily matter so much because it's also going to be figuring out how it maps to a spreadsheet, and because it's semantically
You
similar,
got it exactly.
then it's able to figure it out.
Exactly. What was really important that it gave it to me in JSON structure. That the structure, the overall structure, wasn't something that it could that it could handle and I could handle. But the fields weren't important to me. I didn't want to specify
Yeah.
what the possible fields were because I don't know what the possible fields are. This is meant to
Right.
work with anything. And I wanted it to be able to make those semantic connections, as you point out. So if for whatever reason, my spreadsheet called it total sale, and the gas pump has it labeled as cost or your sale or you owe or whatever, let the LLM make that
Yeah.
semantic connection between the two. And that's a really important component, I think, of both how this works and how LLMs work in general for this kind of
Yeah.
understanding task. Is, there are certainly cases where we want to give it a structured schema, and it's important to do so. But usually those are cases where we're feeding it into
Yeah.
another structured tool.
Yeah.
Otherwise, we
Yeah, I
want
could
it as
see.
flexible as
Not that we
possible.
do this anymore, but I remember like people would come around and they would read the gas meters, right, and take down the numbers on a regular basis. And I could see if that similar type of task needed to be done, that they could take a picture, and so like every of the 1,000 pictures that you take in a month or whatever, they're all gas meters. I could see in that case you could define a structure and say, here's a picture, identify these fields
Right.
in this picture, and I think that LLMs would probably do pretty fine with that type of task. But with spreadsheets, you might want to have very divergent things. Here's my gas mileage. Here's my running log. Here's my caloric intake. Here's my whatever, right?
So here's the CD that I want
Yeah.
to add to my CD collection. Here's what my shopping list is. The whole point of using a spreadsheet is that you're defining the structure as part of the sheet. And the LLM is capable of
Right.
deciphering that structure. And you're giving it, when I'm submitting information, need something similarly unstructured and flexible. And LLMs
Yeah.
give us that flexibility.
Very good. I think we hit all the different aspects of it.
Which is good because we have been talking for almost an
Well,
hour.
it doesn't seem like it's been that long. This has been really fun to kind of delve into what the architecture is and how things play, interplay, and just kind of, it makes sense why you use different features for different things. And I think you've touched on some innovative things like having the system, the AI internal dialogue be surfaced in a way that the users can understand what's going on, so that it's not just some 7, 10, 15 whatever second delay before you get an answer on something, that you understand that things are being processed and what steps are being taken. So yeah, I think there's lots of fun things in this that are innovative, and then the architecture itself is
and
interesting.
most of all, I really hope that people do learn from this and get ideas from this, and that we advance the state of what a user experience in these kinds of chat systems look like, and that this now provides some clues
Yeah,
for how do we do that. It's not just it's great that it can be done. I want to do this. How do we do it? Hopefully, this is giving people some
right.
ideas about how they can do it. So, I hope people have learned a lot from this. I hope the judges, understand the complexities involved here. I hope that has come through in my presentation to them. But most of all, I hope this contributes to the conversation about how to get our large language models doing some amazing stuff.
I definitely want to break out some different things. Like I want to better understand that relationship of how you're using LangChain and LangGraph together. Different things like that. I think there's lots of good conversation that we can have.
Oh, and I am sure we will have this all another time
Yes.
on Two Voice Devs.
Two voice devs. Thank you very much, Alan, for walking me through this whole thing.
Thanks for asking, Mark.